Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve.
Today we are going to do numericals part 3 from chapter 12 electricity. But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all. We have already done first 5 numericals in our previous videos. Today I will be doing numerical number 6. So the numerical says how many times the resistance of the circuit becomes of the previous value if length is stretched to twice its length. Students always understand the language of the numerical. It's better you should read twice. Now, according to the demand in the numerical, it says that we are having a wire which was having previously area A, length L and resistivity rho. Now, what I did that I have stretched this wire like this as shown on the screen. And now after stretching this wire, I observed that rho remains the same, that is resistivity. Why? Because both the wires were made up of the same material. So resistivity will always be same. And after stretching this wire, the length became doubled and the area became half. So always remember, according to the language of the numerical, demand of the numerical, it's better you make the diagram on your own and try to understand and match with the numerical. So I repeat that after stretching the wire, the length became from L to 2L. Resistivity remains the same because it is made up of the same material, and area became half after stretching the wire, that is A upon 2. Now, in the first case, let us find out that is resistance. So R1, we know the formula, R1 is equal to rho L upon A. So I have written over here. Now in the second case, I will take out the resistance, that is R2 is equal to, that is the formula remains the same, rho remains the same in both the cases. Length will change because it is 2L. So instead of length, I will put 2L and area is A upon 2. I have put the value over here. After putting the value, we will simplify. That is rho 2L into 2 upon A. And again, we will simplify more and I will get 4 rho L upon A. We will put it as, in the first case, as this equation 1 and this as equation number 2. Is it clear, children? Now, after we are having equation 1 and equation 2 in both the cases, now what we will do to simplify more, I will divide second equation by 1. So after dividing, how I divide? I divide like this. That is R2 upon R1 is equal to, I will put the values. So after putting the values, I simplify more. After simplification, I get the answer, that is R2 upon R1 is equal to 4, or final, I get R2 is equal to 4R1. So this was for the second case and this was for the first case. That means where I started the initial value. So after getting this answer, I have to put up in words too. It's very, very important, essential to put it in words also in the last. So I found after solving my numerical that resistance becomes 4 times of its initial value. So this is the way to solve the numerical step by step. Again, I'm saying concept is clear. Put your all the concepts step by step in the numerical and solve, and there will be no error, no mistake at all. So this finishes your 6th numerical. Okay, let us come to the
Seventh numerical, very important. Very, very important, children. It's a pretty lengthy numerical, but it is very easy. If you, again, I'm saying, if you know the concept, your concepts are clear, you can implement step by step in the numerical. Okay, students, let's start. Find the effective resistance of the below circuits and total current. Now in the numerical, children, they have given you these both circuit diagrams. And they have asked you to find the effective resistance and also about the total current in both. Now, if you children observe, first of all, whenever these type of numericals are given with the circuits, always observe the circuits first before starting anything. How they are arranged, whether they are in series or parallel or whatever, what is the volt and whatever it is given, let us recall in our mind first. If you see the first diagram, let me show you. See, this is the first diagram. This was the original diagram. This was the original diagram given in the numerical. Now, how I have studied this circuit diagram, this I'm going to elaborate step by step. If I see this was the original diagram, now what I have done with this diagram is, if I view this diagram, I have seen that this shows the same path. Again, I repeat, this shows the same path. That is, this is in one wire only. So if it is the same path, therefore, this is series. Yes or no? This is series. So I will put up the formula of series. That is the RS stands for resistance in series. Again, I repeat, this is the same path. I will put up the formula of resistance in series. That is 3 ohm plus 3 ohm, I get 6 ohm. So my first step is solved. When I have solved this first step, when I have taken out of series, I have detected that this is the same circuit, that is the same wire, same path. So I will put up the formula of resistance in series. I have put up and added the 2. So I got 6 ohm. Finished. Okay. Now, if I have done the calculation of this, so what I really feel that if I've taken out the answer 6 ohm, so I will remove all this as I solve the calculation. I will start removing the circuit so that I do not get confused while solving next step. So to make it easily, that is to make out my things easy, that is to go on in a very easy manner, I will remove this one by one. So this is all finished. It is all over. So whatever I have done the calculation that I've added this resistance in series, I've put up this as this and I've put up whatever I have calculated over here, 6 ohms over here together. Instead of putting separately when I've solved, I have put up this 6 ohms which I've calculated over here collectively like this. When I have kept up this 6 ohm collectively like this and this is all over, I observe that this 6 ohm which I calculated after adding up it in series, this became parallel with other circuits. Look at this 6 ohm, 6 ohm, 6 ohm. So one under other. So that means 6 ohm, 6 ohm, 6 ohm becomes parallel. So viewing this 6 ohm in parallel, what I will do? I will put up the formula for parallel. So what I've done? 1 upon Rp. Rp is resistance in parallel. So that I have put up 1 upon 6 from here plus 1 upon 6 plus 1 upon 6. Solve it, children. So after solving, I got 3 upon 6. Again, more solve it. 1 upon 2 and 1 upon Rp, that is resistance in parallel, is equal to 1 upon 2 or Rp is equal to 2. What is the unit resistance? That is ohm. So this is the effective resistance which I have taken out, calculated in the first case in the first circuit diagram. This is finished. Am I clear? So my main motive is, as I keep on solving, I will start removing the circuits which I have solved, and I will make it a separate circuit on my own so that my calculation becomes easy in future, so that I do not get confused. So the first calculation is done in the first circuit diagram. Finished? Okay, let us come to the second circuit which was given in the numerical. So now this was the circuit which was given in the numerical, and how I have studied this circuit. Look at over here. Now, if I view this circuit, I see that this is in the same path. That is, this is the same wire going on. One wire going on. That is the same path. Now, if I have observed the same wire, again that means it is resistance in series. So what I will do, I will add up 3 ohm plus 3 ohm. This gives 6 ohm. Why I've added up? Because it is in one wire, same path. And I will put up the formula for resistance in series. And then I will calculate, which I have done it over here. 3 plus 3 gives you 6 ohm. So this is resistance in series. Now after this, what I will do when I've solved this, I will remove my circuit, this one, and then whatever final answer I got of 6 ohm, I will make this circuit and put up 6 ohm over here. And I will remove this circuit permanently. Yes or no? Because I have calculated a new, that is the answer over here for resistance in series, and then I will remove this to make my calculation easy in future. Okay. Now, after putting this 6 ohm, I came to know after studying my circuit diagram that whatever I have put up 6 ohm over here, this has become parallel to this 3 ohm. Okay. So if it has become parallel, so I will put up the formula of resistance in parallel. So what I have done it over here, I have put up the formula for resistance in parallel. That is 1 upon Rp. Rp is nothing but resistance in parallel is equal to 1 upon 6 plus 1 upon 3. Please solve it, children. You know how to take out the LCM and then solve it further. So after putting the LCM of 6 and 3, I got 6, and then further do the calculation. That is 3 upon 6. That is 3 ones are 3, 3 twos are 6. I got 1 upon 2, and then solve further, which I get the answer in the last of resistance in parallel is 2 ohm. Oh my God, to my surprise, that the effective resistance in the first case, in the first circuit, I got 2 ohm. And also in the second circuit, second case, I got 2 ohm too. Okay, so that means effective resistance is same in both the cases. Wow, great. So children, always and always, whenever you get these kind of numerical, giving the circuits and all, please solve and start discarding the previous circuit so that it becomes really very easy your calculation further. Okay, after calculating the effective resistance, now what I have to do? Okay, after doing this, I got, see over here first, that is I got 2 ohm over here. Yes, so that means after calculating, I got 2 ohm. Okay, after this, children, when I have done this 2 ohm calculation, so what I want to do it, I will discard the previous circuits. Okay, I've discarded. See this red portion, I have discarded. I don't want to see this. I have discarded this portion. And whatever answer I got out of this, I got it 2 ohm. So I have put up 2 ohm over here after discarding the previous circuit. Okay, fine. Now, after putting this new value, new calculation, new answer over here 2 ohm, then I observe again that this is the same path going on, okay, in the circuit, 2 ohm and 2 ohm in the same path. And this is what, that is we have joined over here, right children? We have joint over here, that is a separate circuit. So resistance in series, I will take out because this is in the same path, same wire, and this is the joint afterward. This one is the joint, and this is the wire which is in the same path. So what I will do, I will calculate resistance in series. So 2 ohm plus 2 ohm, I got 4 ohm. Now 4 ohm is, now after calculating this, now 4 ohm has come the answer. Now this 4 ohm which we have calculated now freshly, it is now parallel with this 4 ohm. This is now parallel with this 4 ohm. And this we have a joint, that is why we know it is in parallel with the value which we have calculated over here. Okay. After this, now this and this value which has come out to be 4 ohm is parallel to this 4 ohm. So again, we will put the formula of resistance in parallel. See over here. 1 upon Rp, that is resistance in parallel, is equal to 1 upon 4 plus 1 upon 4. Calculate, children. 2 upon 4. Please do the calculation further. 1 upon 2, or Rp is equal to 2 ohm. Wow. So this is also resistance in parallel, that is 2 ohm. So this is also done. This is also the effective resistance. So for all the circuits, we have taken out the resistance in series and resistance in parallel according to the demand in the circuits which we have observed after calculation, the fractions of calculations. That means it can be in the resistance in series or resistance in parallels. After doing the calculation in fractions, we have come to the conclusion with the effective resistance in everything. After this, when we have the effective resistance, so they have also demanded to calculate the current. Now, according to Ohm's law, we know it that V is equal to IR. Very nicely, we know it. We have done it. We are clear with our concepts. Or we know that current will be, that is V upon R. That means we can take out this formula with our previous, that is formula V is equal to IR. Yes. So now current is equal to V upon R. What the value is from the first case? That is current is equal to, what is this? It was given in the numerical already 20. So I put up 20. And resistance I have taken out just now. That is, it was 2 ohms, put the value. Please do the simplification. So the current has come out to be 10 amperes. Oh God, lot. Yes. So let us do for the second case. So that is the same formula. I is equal to V upon R. So current, that is 10 was the volt, that is V, and 2 was the what? Resistance which we have taken out. And then after doing the calculation, the current comes out to be 5 amperes. So this is the current for the circuits which was given in the numerical. So students, always and always remember, this is really very important. What? Numerical. But it is not so difficult. Yes, I can say it is really very lengthy, but not difficult. Why I'm saying it is not difficult? Because children, if the concepts are clear, you can go like this, like a chain reaction, and then you can solve it in a fraction of minutes, children. If you practice today during your exam, it will be very easy because you have done the practice. And children, always remember, these kind of numericals will only come one or the other way. They will only change the values or the circuits or whatever. If you know the concepts, do the calculations with fraction of answers. I mean to say, take out the answers in fractions and remove the previous circuit, make the new circuit, and then see whether it is coming now in parallel or series, and then keep on calculating. After knowing the effective resistance, you can take out the current, putting the formula according to Ohm's law, and take out the current. So this is very easy, children. Rewind my videos. Keep on solving again and again. Again, recheck. Again, redo. Again, rewind the videos. Keep on watching. And then in the last, do it on your own. Always remember. But children, only oral watching videos will not make you perfect. You have to do it with your hands. which will really make you perfect in doing it. And moreover, make a chart of your, the formulae, and then you can put it in your room on the wall or on the softboard, and day and night, please revise those formulae, and you see your concepts will be very, very clear, and you can solve the numerical in fraction of minutes. So with this, children, I wind up the session. Bye-bye. God bless. Take care.